Hi there. In this video, we'll learn about an issue in IRR, which is actually the presence of multiple internal rates of return. Let us see how it happens. It's basically due to the unconventional streams, and the unconventional streams have multiple switches in their signs, because in the conventional streams, the sign switches only once. Initially, the sign is negative of the net benefits, and then it turns positive and it remains positive. But in these unconventional streams, it will change more than once, due to which we have a kind of situation where we can have multiple internal rates of return. Where the negative NB arise again after the initial years, IRR has multiple values. So this possibility that negative net benefits have risen again as they were there in the beginning, and that makes sense because in the beginning there is capital costs, but if it is happening that it arises again, it means that there has been some heavy cost. Maybe it's due to environmental cleanup, that cost which has to be incurred if there is an activity of cleaning up the environment, some negative externalities. So that will give rise to second switch in the net benefits. This was the first switch, that is from negative to positive, and this is the second switch, that is from positive to negative. We expect there will be two IRRs in it. We can calculate this, and for that we are going to make a table in which the first column is about the discount rates and the other is about the NPVs, remarks, and then the signal for IRR. Here we have the discount rates, and we are starting it with 1%, and then we are continuing it to 30%. And at each discount rate we have calculated the NPV. Here the NPV is minus 15,266.23, and when we increased the discount rate, it further changed, and now it is minus 5,677.24. So we have this change, and that change is evident, but the sign has remained the same. But when we increase it further, it becomes 3%, and the NPV is now this much. So you see, this process will continue as we continue to increase the discount rate. And initially we could observe that the negative NPV was due to the initial costs, but then the positive NPV arose because of the benefits that we started to glean after a few years. But the initial costs, they are there, and they can give rise to negative NPV. But when we go ahead, we can see that, so we further increase the discount rate, and we see that the NPV is also varying, and it is varying in such a way that primarily it increases, but after this point it starts to decrease, that is after 12%. So now it is further decreasing as I'm increasing the discount rate, and you see that it is now further declining. Now this is 27% discount rate, and at this it is still positive, but afterwards this is negative at 28%, and then 29%. It further decreases in terms of its negative value, and these can be attributed to the environmental cleanup costs. All of these factors, they are working, but there is one thing that we need to observe, and this is this unusual trend, because when we used to increase the discount rate, the NPV used to decrease, but here it is increasing up to this point, and then it is decreasing after this point. So this can be attributed to this negative net benefit at the end, which has created something unusual, due to which the relationship between IE and NPV is not as it is usually for the first 12% discount rates. Now, this is the first switch in the NPV, and this is the second switch in NPV. Now we can try to find out the IRR at 2 points, because between 2 and 3% there can be an IRR, as the NPV, the net benefits or the net present value, it has changed its sign. And it can also be found between 27 and 28, because the NPV has turned negative from positive. So there can be two of these discount IRRs. This is the NPV profile. We have plotted all those values that we just calculated, and you can see that it has a positive relationship initially, which is unusual, but this is the relationship that we have been studying before. This is a negative slope of NPV. So this is how we can plot this diagram, and this is the point where NPV is 0. This is another point where NPV is 0. This means that we have two IRRs, and this IRR is between 2 and 3%, and this is somewhere between 26 and 29%. Let us see that how these values can be calculated simply by using the interpolation formula that we have used before. The first IRR can be calculated by considering the formula of interpolation, and in that usual formula of interpolation you can see that we have introduced the first superscript, because now we are using the first formula for the first IRR. Putting these values and solving it will give us the first IRR, which is definitely between 2 and 3%, as we saw in the diagram and the table. And then we have second IRR, and for that you can see that the substitution has taken place, and now it is the second IRR that we are calculating. So here we are, we can solve this, and we will get 27.741. So this means that the expectation is becoming true. It is somewhere between 25 and 30, or it is approximately 27.7 or 28%. So due to this, what we can understand is that there is a problem or confusion with the IRR thing, and it happens when there are unconventional or non-traditional streams where the negative values creep in again, usually at the end, or in other words, the values, they switch not once but more than once. And in this example that we did, the switching happened twice. So NPV is usually free of this multiple switches problem. This is why NPV is usually used, and we do not use IRR that frequently as we use the NPV criterion. So this was the table that we used. We also saw the diagram, and this was the stream of the net benefits, which was unconventional or non-traditional, having two switches. And this is how the problem in the IRR is understood with the help of example, that it can give us a dilemma of IRRs where it becomes difficult to choose between the two. Modified internal rate of return is recommended in such a situation, which is not in the scope of our course at this stage. Therefore, NPV is recommended in this kind of situation. Thank you.